Precalc. This is 4.2 day 2. Today we're going to talk about the properties of logarithms. And so this works for any of the bases. B, you will have these properties that if you have log base b of 1, it'll equal 0. So I guess what you're going to see on these is you're going to be not given what it's equal to. You're going to have to start to realize that the way, remember that a log is set up, it's the base to the power of something equals 1. Well, what power will make it always equal 1? 0. Part 2 is log base b of b is equal to 1. b to the first power is b. It makes sense. When you kind of switch these to exponential, it helps out a lot more. And b to the x is equal to b to the x. Remember, logs are like exponents. And so if you have an unknown base, you raise it to a power, it's going to be raised, has to equal b to the x. b to the x is equal to b to the x. This one's an important one, because when you see, and we're going to have an example of that obviously in part C here, log base b of something with the same base, the bases basically cancel each other out, and you're left with whatever the exponent is. And vice versa, some base raised to the power of a log with the same base, the value is equal to whatever's inside the log. So we got an example of all 4 of those. Log base 5 of 1 is equal to 0. Now, one way to think about these guys is to say, wait a minute, I don't know what this equals. So what if I let that equal x? What if I switched it then to exponential? 5 to some unknown power is equal to 1. Oh, then x has to be 0. Right? You could think of it this way as well for part B. Log base 5 of 5, I don't know. Let me call that x then. That means 5 to some power is equal to 5. Right? 5 to the power of x is equal to 5. Well, the only way, and remember that's 5 to the first power, only way for these two numbers to be the same, with their bases the same, is if their exponents are the same. So that means if I was to simplify this or evaluate, log base 5 of 5 is just 1. I wouldn't even say x equals 1 because we introduce x. So it just equals 1. What about C? All of these, pretty much I can do that too. D, I guess it would be a little different. But again, I can still set part C equal to x if I want. 5 to the power of x equals 5 to the 8th. That means it has to be what? 8. So you're going to have to recognize that. You're going to have to evaluate them individually, sometimes together. Put a couple together. So be very mindful of that. Part D, when the base has a log with the same base, we say they cancel each other out. The answer is 12. In this case. Then what we have now is we have the actual names of common log and natural log. Common log, guys, in the natural log are those buttons on your calculator. Those are the only ones your calculator has. Now we are going to have the ability to evaluate and solve or figure out logs in any base. But your calculator knows how to do log base 10 and log base e. So the common log is a logarithm with base 10, and we now just write log of x instead of log base 10 of x. So it's kind of a lazy mathematician's way of starting to use logs. I don't want to keep writing that little base number. So to get rid of the base number, I just use log. And if I just see log, I assume it's a 10. Or should I say, I know it's going to be a 10. This is on your calculator. You're going to have a group of your homework, so potentially it does this. Take your calculator out and evaluate log 5. Or log of 1,000. Log 5 is really log base 10 of 5. It's probably going to be some decimal answer, right? What does that one end up being? Log 5. Someone? Louder? 0.4? 0.47?
No,
0.7. I heard 4 first. I don't know. Sorry. 0.7. Log of 1,000? It's 3. You could do that one without a calculator, I hope, because 1,000 is 10 to the third, right? You guys agree that this would be log of 10 to the third? But really, there's supposed to be a 10 in there, and the 10s would cancel, leaving you with 3. So that's one way you can do ones with calculators, without calculators. And then you got natural log. The natural log is a log base e. So instead of, we're getting a little lazier, we don't want to write log base e. Log base e. E is used quite a bit, especially when you get to calculus and stuff like that. So instead of log base e, they use ln, natural log. Natural log of x. Log base e of x. And so they are interchangeable. Notice, just like before when we're dealing with logs, now the natural log of e is e to the x equals y. Or actually, sorry, that should be an x, sorry. Well, I kind of think let's fix this. Let's do natural log of x equals y. So, therefore, e, which is the base, to the y is equal to x. These are interchangeable. This is also on your calculator, as in natural log of 4. If you put natural log of 4 on your calculator, sometimes remember what kind of calculator you have. You may have to put 4 and then natural log. If you have a graphing calculator, it's natural log and then 4, hit enter. This one will be like 1.386 or 3839, something on those lines. What does it mean? It means e to the 1.38 power is going to equal 4. So just to kind of highlight those properties from the last page of any base, they changed it so you don't see log, you see natural log, which you should then realize is log base e. So that means e on number 1, natural log of 1. Well, the log of any log base of 1 is still 0. So e, log base e of 1 is still also 0. Log base e of e. You're starting to see that some of these rules from the last time, they're the same thing. It's just that I'm placing a base of e. And so they're purposely putting things in there that make it work. So like in step 1, you get log base e of 1 equals 0. I think it's a lot easier to write ln versus log base e. So e to the 0 is equal to 1, of course. Part 2, now you have log base e of e equals 1. Well, we showed on the last slide or two that, yes, if this happens, it's e to the first, and e to the first is e. Or the e's cancel away, leaving you with their exponent, which is not there, but it really is. It's a 1, and it makes sense. Same thing with 3 and 4. So it's just using the properties from the last page. So just to kind of put that in perspective, what's a? It's 8. The natural log and e will cancel each other out because the natural log is log base e, so you're left with 8. Part B, that's a little interesting. Natural log of 1 over e squared. What's the answer to that one? It is negative 2. How'd you get negative 2? I don't like exponent, maybe I don't like my exponent on the bottom, right? Where can I bring the e squared? Yeah, if I bring it to the top, this would be e to the negative 2, and now the natural log and e cancel, which leads you to 2. Natural log of 5, you have to put that on your calculator. We already did a natural log of 4 and stuff, so I'm not going to do that problem with you guys. So, any questions? So, if it's something you can evaluate and get a nice number without a calculator, go for it. Part C, you would need a calculator. Again, I think that would be something less than squared, some 1 point something. Okay. Can you, now using those properties from the last page, evaluate these? So using the properties from the last page and switching from log form to exponential form, can you solve or evaluate these? To find x. Log base 3 of x equals 5. What do you think we should do? What's that?
Set up an equation.
Set up an equation. What do you mean?
Well, would you say 3 to the 5th power is equal to x?
Yeah. I would say a little bit of words of switch it to exponential form. So 3 to the 5th power is equal to x. Well, that's pretty easy to solve for x now. What's 3 to the 5th power? 243. Done. Do the same thing for part B. What would that be? 4 to the x equals 16. 4 to what power is equal to 16? 2. Done. So again, solving logs is not necessarily the easiest thing, but if you just switch it to exponential, you're good to go. Now, one thing they're going to do to you, before I take a question here, is that they may take the equals x out of there. And that's just like I was showing before. If they want you to evaluate now, part B, and you're like, I don't know, it doesn't give me any variables. What do you mean? It means find the number. Find out, because remember, logs are exponents. So go back and say, oh, that equals, whoops. I'm going to let that equal x. So therefore, it leads me to 4 to the x power equals 16, so I can solve it. And the last problem we're going to talk about is finding the domain of log functions. And okay, so you need to know, guys, is that all log functions are defined as x is greater than or equal to 0. Now remember, when I say that, though, I am basing this off of this. Log base b of x equals y, or natural log of x equals y. So x is the part that you put inside the log, right? It's defined that that has to be greater than or equal to 0, or greater than 0, not even equal to 0, because you can't take a log of 0. So all you need to do is figure out what's inside the log and set it greater than 0, solve. So for our example, f of x equals natural log of 4 minus x squared. What's the domain? Well, the domain is, just the inside part, 4 minus x squared, greater than 0. Solve it. Now, this can obviously get a little tricky in itself. I think everybody should agree that I'll add x squared to both sides. So I'll get 4 is greater than x squared. And then take the square root plus or minus. So I'll get plus or minus 2. But wait a minute, I got this greater than symbol. Something about this doesn't seem right. What's going on here? Flip it. Why do I flip it? When do we flip the inequality symbols? When it's a multiplying or dividing by a negative. So I don't say we got to flip, but I think we do have to flip. That's the thing. One of these, you can't be less than, well, actually, in this case, you can be less than 2 and negative 2 at the same time. But a lot of times, you got to remember, this is an inequality. This is a parabola, right? It's going to cross. It's going to cross at 2 and negative 2. Or 2 and positive 2. Where is it, according to up here, the very, very beginning, where is that parabola greater than 0? It's greater than the 0 here, and it's greater than 0 here. Made a mistake on here, on this little drawing. What did I make a mistake so far of? I found my critical points. Technically, I could change this to an equal sign to find my critical points. It's plus or minus 2. So I put them on here. What was my... I think I did wrong.
Isn't it supposed to be like this?
Oh, up and down. Okay. That's okay. Now we got 2 mistakes. I realize there's another one, though, yet too. I'm going to regraph it because of that. Okay, it goes this way. Yes, it should open down, not up. But what's the other mistake? Open or closed? Open dots because you can't be there. That was my other mistake. They're open dots at negative 2 and 2. And if I have this drawn this way, what would be the answer for where this graph is greater than 0? Where is the graph greater than 0? It's where it's above, right? Here. This part. So it's all of these. So the answer to this question, it's not all real solutions. It's from negative 2 to 2 with what on the h end? Parentheses, because it can't be equal. So the domain of x such that, I ran out of room, x is on, boom, if I want to formally say it, domain x is, or such that x is contained in negative 2 to 2. Or, if you didn't like that, negative 2 is less than x, which is less than 2. Inequalities and interval notation. Are there any questions, guys? Hey guys, page 356, 18 through 21, 28 through 29, 31, and 58. Have a great day.